side lengths you want. Okay, you can't just say, oh, here's a triangle and pick 3 random side lengths. It has to fit a certain rule. All right, so for instance, if I have a triangle here and I just throw up, I'll make this side 3, this side 5, and that side 20, that won't form a triangle with those 3 side lengths. It has to fit a certain rule. The side lengths have to fit a certain rule, and that's what you're going to do in this activity today is find that rule. All right, to form a triangle, the 3 sides must do blank. All right, and you're going to fill in that blank right now. So you guys are going to do a little activity here for me. You can see here it says each member of your group should take turns picking 3 straws. That's not going to happen in this class anyway. I'm not going to go down to the level of straws. My students are better than that, so I have licorice that I'm going to give you right now. All right, each group's going to get 3 pieces of licorice. All right, 3 pieces. Your first job is to do the following, and it looks like everyone's got rulers with them, or at least a couple rulers within your groups. Each group is going to take the 3 pieces of licorice and divide them up into a 2, 3, 4, 5, and 6-inch piece for the whole group, not each person. Right? So the whole group should have 2, 3, 4, 5, and a 6-inch piece. That's your first job. And then I'll tell you what your second job is here after you're done with that. All right, so let's do that first. So start dividing them up. Make sure you know which piece is which for the second part of the activity. After everything's done, you are allowed to eat them, but not until we're done with the activity, though. You're going to need these bad boys. All right? So start dividing them up for me. Everyone always asks, how am I going to cut them? That's not my problem. You guys figure it out.
Okay, somebody figure it out. Got it. You figure it out.
Plus 2, 3, and 4, 5, 6.
If you mess up, let me know. I'll give you an extra piece. But I need a 2, a 3, a 4, a 5, and a 6-inch piece within your group right now. Let me know if you need another one.
So 2, 3. You have 5.
No, that was 4.
So we need 5. So do we need 1 more piece?
This is step 4.
5.
Let's get those pieces cut so we can move on to the second part of this.
You wanna eat it? Yeah. Was that 2, 3, 4, 5? Yeah. That's like that. Okay. Wait. Shoot, is that one? They're both. Okay, that sounds good. What was this again?
All right, we all have our pieces now. All right, next job, the most important job. You're going to select 3 pieces right now. All right, you're going to select. Hold on, let me get through everything. You're going to select 3 pieces. Write those 3 pieces down. All right, in order too. Like if you do a 4, a 5, and a 2, write 2, 4, 5 in that least to greatest, please. Smallest to largest. And what you're going to do is in your group, do those 3 pieces form a triangle or not? All right, and here's what I mean. It's got to touch each vertice perfectly. If it comes up short, that's a no. If it goes and forms an exterior angle, that's a no. It has to touch all the vertices perfectly. So here's what I want from you and your group. I want you to find 3 sets of pieces of licorice that do form a triangle and 2 that do not. All right, so that's your job right now within your group. Take 3, write them down. Will they form a triangle or not? I want 3 sets that do, 2 sets that do not. Go ahead, and then we'll report back here. Also, if there's controversy and you guys can't agree, call me over. I'll let you know what it should be. Yes or no? 2, 3, 5 should have been enough. 2, 3, 5 should have been enough.
That's 5. Or is that 6?
4 and
If it's debatable, call me over and I'll settle the debate.
4.
So what was that? 2, 3.
Or
2, 3, 4. I think that was 2, 4, 5.
5.
This is 5. I think that's 4.
Does it mean like that? Or like how are we lining them up?
3.
Yeah.
6, 5.
Third. Yeah.
Was that, so what was that? 3,
I
4?
would say that's pretty much it.
3 yeses and 2 nos, please.
What? What was that?
That's 3, 4, 6.
4, 3. There's 3, 4, 6.
Wait, what was that? 4, 2.
Was 3, 4, 6?
I would not call it triangles.
What's your?
No, it was, oh yeah, you said 4.5.
That's no.
Oh, you're interested.
We didn't, because it was technically 4.5.
Just search them together because that's
2,
5, 4.
And
Wait,
5,
which ones are extra and which ones?
2, 3.
You only
need
to.
Okay.
I call it a triangle.
Yeah, is that an extra or is that
5, 4, I think.
Oh, or 5 was 2 combined, remember?
Yeah, oh yeah, this one was like this one.
5, 4, 3.
Maybe, okay, so this one.
4, 3. 4, 5, 6.
So how's track going?
Yes.
Oh, you do.
Okay, let's start reporting back here because I want you guys to find a pattern between the yeses and the nos because something happens with the sides of the yeses that do not happen with the sides of the no. So any group will want to start off with a yes one. 3 sides. What's up, Is? 3, 4, 6 is a good one. Yep. 3, 4, 6 does form a triangle. Yes. Others that form the triangle? Keating?
2, 3, 4.
2, 3, 4 should have also formed a triangle. That looks good. All right. Others? Yep. What do you got, Hayden?
4, 5, 6.
4, 5, 6 is a good one. Anybody want to add? I know I asked for anybody want to add more that you had? That's not up here. I'm sure there was more that maybe you wrote down, but I don't have up here yet. More the better here. Jonathan?
2, 3, 5.
2, 3, 5. Yep. That should have been a no. 2, 3. I'll put that in the no column. 2, 3, 5 should have been a no. Which is fine. We need some no's here. Any other yeses? What do you got, Zoe? 3, 4, 5. Yep, that should have been a yes as well. All right, so I'll leave those 4 up there. Those yeses. All right, give me a couple more no's. I already have 2, 3, 5. Anybody find any other no's that did not work? Did not form? Mia,
1, 4, 6.
what do you have?
1, 4, 6.
You had a 1 in there.
Oh wait, 2, 4.
2, 4, 6. There you go. I was going to say. Yep, that was a no. And anybody have another no? Because there was one more out there. Keating?
2, 3, 6.
2, 3, 6 was a no. Yep. All right, so here's back to work with your groups right now. You're going to look at your chart, my chart. You're going to look at the yeses and look at the nos. What rule what rule do the sides need to follow for it to form a triangle? And then it does not follow this rule when it does not form a triangle. Write your thoughts down where it says summarize a conclusion. This is where you get to write your own stuff before we make it official at the bottom. All right, so discuss it in your groups right now. Why did those sides become a yes, but the sides down below became a no? What's so great about the yeses that don't follow the nos? Because there's something there. Cannot be any side you want. It's got to follow a rule. Got to follow a rule.
Yeah.
Okay, I see that.
Just write down what you and your group think, and we'll make it official here in the box in a minute.
Like numbers, how you count, kind of thing. It's kind of what I meant.
All right, well, if I'm going to form a triangle, what's your thoughts here? What do you have to know about the three sides of the triangle if it's actually going to form a triangle? It can't be any three sides. You guys just saw that. Can't be 2, 3, 5. Can't be 2, 4, 6 or 2, 3, 6 because what's it got to do? What do you go, Mia? In your own words, and then we'll make it official.
They said if 2 is the shortest side and 6 is the longest side, it doesn't form a triangle.
What if I had... All right, you're using 2 specific numbers. What if I just gave you 3? Here's my thing. If I gave you now, forget about 2 through 6. What if I gave you guys 7, 8, and 11? Are you going to know if that's going to form a triangle or not? That's what I want by this rule that you give me. It can apply to any 3 sides, just not the 2, the 4, and the 6, or the 2 and the 3 and the 6. It can apply to any 3 sides I give you, okay? Which we're going to keep moving on there. Anybody, in general, what do you got to know about the 3 sides? You're probably going to be right. Like if I give you 7, 8, 11, will that form a triangle? If I give you 10, 20, and 25, will that form a triangle? What's the rule you guys are coming up with here? You got it. You got it. Go ahead, Izzy. What's up? In your own words.
Like the 2 of the smaller values, so like if it was 3, 4, and 6, like 3 plus 4 equals 7, it's greater than the third one.
Okay, so what you're saying is add up the 2 smaller sides, and it always should be bigger than the final side, the third side. How's that sound? All right. I'm not going to say the 2 smallest sides. Here's what we're going to write down. You add any 2 sides, it must be bigger than the third side. All right. Take a look. Why didn't 2, 3, 5 work? Add 2 and 3. What do you get? Is that bigger than that third side? No, it's equal to. Why didn't 2, 3, 6 work? What's 2 plus 3? 5. Is it bigger than the third side? No. All right. So see why these aren't working versus these now. Add up any 2 sides. It must be bigger than the third. So let's write that officially in our triangle inequality theorem. In a triangle, got to start out with that because none of these facts work in a square, a rectangle, rhombus. In a triangle, the sum, which means I'm going to add them, the sum of any 2 sides must be greater than the third. Any questions? I know we're going to do a few examples here, but any questions? Add up 2 sides. It's got to be greater than the third every time. And yes, just going back to Izzy's point, the trick is look at the 2 smaller sides, add them up. If it's bigger, it's probably automatically a yes or a no. All right? All right, so let's practice this. Number 1, I got 5 different types of triangles up here with side lengths. I'm going to go around calling each of you. See if it forms a triangle or not. Remember, the sum of any 2 sides needs to be bigger than the third side. Okay, so look, will 1, 2, 3 work? If I have a triangle with sides 1, 2, and 3, are the sum of any 2 sides always bigger than the third? If not, it's not going to form a triangle here. So Zoe, is that going to work?
No.
Nope, because everyone, 1 plus 2 is 3. It's got to be great. Even though I know some of you could argue, well, 3 plus 2 is bigger than 1. True, but as long as you find one that doesn't work, it's not a triangle. So 1 plus 2, not bigger than 3. That's why that one will not form a triangle. How about 2, 4, 5? Will that form a triangle if I have sides 2, 4, 5? Izzy, 2, 4, 5? That will work. Yep. You add any combination of two sides, always bigger than the third. Always. 5, 5, 6. Will that work? If I have a triangle, side lengths 5, 5, and 6. Is that going to work there, Jonathan?
Yeah.
Yep. In fact, what type of triangle is that? I go a little deeper here. 5, 5. Isosceles. Yep. Isosceles. How about 8, 13, and 21? If I have three sides, 8, 13, and 21, will that work? Where am I going on that one there? 5. Sydney? Nope. 8 and 13 give you 21. It's got to be greater than 21. And then finally, how about 10, 20, 25? I know larger numbers, but 10, 20, and 25. Yeah. Is that going to work?
Yeah.
Yep. Add up any two, it's always bigger than the third. All right, everyone good there? So that's one thing I need you to do with the theorem. If I give you three sides, tell me if it'll form a triangle or not. Second and final thing I need you to do, if I give you two sides, what are possible third side lengths? All right, what are possible third side lengths? So please don't write anything in as an answer. It's going to take us a while here to get the answer, probably about 5 minutes. I just want to do all the work here off to the side. So I got 4 and 7. First thing I want to do with you is write the possible lengths it could be for the third side. And it's got to fit into our rule. So I don't want somebody to give me 25. That's not going to fit into our rule. That's not a triangle. All right. So somebody want to start us off here. What could be a possible third side? So when I add up 2, it's bigger than the third. Or it's a possible. Hayden, you want to start us?
12.
What's 4 plus 7?
11.
Is that bigger than your 12 you just gave me?
Oh.
Right? See what I mean? Yeah, good. That's fine. We're making the good mistakes here, right? It can't be 12 because 4 plus 7 is not bigger than 12. So it can't be 12. And go ahead. Let's get another one. There's a lot, Lennon. 5 works. Right? Let's see. 4 plus 5 bigger than 7. 7 plus 5 bigger than 4. Yep, 5 works. Others? There's more than that. Jesse? 10? Let's see. Does 10 work? 4 plus 7 is 11. That's bigger than 10. That's good enough for me. Jackson? 4. Let's see. 4 going to work? 4 plus 4, everyone? 8, bigger than 7. 4 works. Okay, now we're starting to roll a little bit now. Good. 6, 7, 8, 9. How about 11? I got 10 here. How about will 11 work? No, because 4 plus 7 is 11. It's got to be greater. All right, so nothing bigger than 10 here. Can we go this way now? Would 3 work? A side of 3, would that work? That 3 and 4 gives you 7. So it looks like we have all the possible lengths right here. But I don't want you to list them out every time. That's not the answer I want, is 4 through 10. Because honestly, if I gave you different numbers, it could be a huge set of numbers. What I want is this written in. I'm going to go back to Algebra 1 last year. Hopefully you guys did this. Did you guys use inequalities last year, less than, greater than? And did you do problems where it had 2 inequalities in the same one? It was called a compound one. That's what we're going to do right now. We're going to take the letter S, standing for side, and we're going to say the sides have to be in between. You tell me, based on the work we just did, what should the sides be in between? 4 and? Okay, all right. Oh, I wouldn't write that as my final answer. I'll do it up here on the board. Stay with me. But didn't you say 4 could have been 1 and 10 could have been a side, right? So anybody remember the adjustments you needed here? The or equal to. Don't write it, though. Don't write it. So that's what I have written here, right? We got a problem. We still have a problem. I need your answer. Could my third side, think about it before you say yes or no. Could it be 3.9 that side? If I add up two sides, is it bigger than the third? Could 3.9 be a side? Yes. 4 plus 3.9 is bigger than 7, but there's a problem. Is 3.9 part of my inequality we just wrote together? All right, hold on. I'm still not done. Tell me if this could be a side. How about 10.1? Could 10.1 be a side? 4 plus 7 bigger than 10.1? Is 10.1 bigger, is part of our inequality or not? Nope. All right, well, I hate to break it to you, that's not going to work. All right, so you and your group got to help me out. I'm going to leave those blank again. You tell me what should go on the edges now, because it can't be 4 and 10 with the or equal to. Discuss it in your group. Give me a good one that includes everything now. That includes everything. Talk to each other here a couple minutes. Give me a good inequality that I can write in now. Because 4 and 10 with the or equal to is not cutting it. It's got to be something else. So what's it going to be? That includes 10.1, 3.9. What do you got for me now? What should be the ends now that include everything? Nothing? What do you think, Keating?
3 and 11.
All right, let me check. Let's check. Should I put the or equal to?
No.
No, because we already said no 3, no 11. All right. Does that include 10.1? What else did I have up here? 3.9. Does that include 3.9? Yeah. So that's a good one right there. All right. That's the one I'm looking for. Between the sides have to be somewhere between 3 and 11. All right. So that's a good one. Problem though I have, that took us 5 minutes to do, I think. That's a long. Do I want you to every time you do a problem like this, list them out, think about, oh, it's got to be, is it or equal to, is it not? No, I don't want you to do that. There's got to be some way we get to that a heck of a lot quicker than what we just did. Heck of a lot quicker. So there's got to be like a little trick in there that can lead me to the 3 and 11 a lot quicker than writing out all the darn possibilities. What sides did you start out with? What are the two sides I gave you?
4 and 7.
Oh, 4 and 7. 4 and 7? 4 and 7? What ended up being the sides that had to be in between then? 3 and 11. How can I go from 4 and 7, the given sides, to the end of the inequalities there, 3 and 11? Subtract them, you get 3, and add them, you get 11. So that's how we're going to get a lot quicker to figure out what the sides are in between. Look at number 3. Now I'm doing 9 and 17. Instead of sitting here and going, all right, somebody give me a side, somebody give me a side, somebody give me a side, and then determining the inequality, we can go a little quicker now. Subtract those sides. What do you get? 8. So at least I know my side has to be bigger than 8. But go ahead and add them. 26. My side has to be less than 26. That's how I can get that third side much quicker. Because we'd be, look, between 8 and 26, we'd be here for more than 5 minutes listing out all those sides. And then finally, if my side is 11 and 20, go ahead, subtract them. My third side has to be bigger than 20 minus 11. And it's got to be less than 20 plus 11, 31. All right, so that's how I can get to those sides much quicker. Hey, get out of here. You guys know motivation here. Get out of here without any assignment for the break. Yep. One tab open up to the textbook page, the other tab open up to the answer key. Get out of here without any assignment for break.